Okay, ma'am. So, next topic which we are studying is AC, alternating currents. Okay. See, my current flow of current I can divide into two types. One is direct flow and the second one is alternating flow. Okay, ma'am. What is meant by direct flow? See here. For example, in this circuit of resistance R, I connect a battery, DC source of battery. Then current flows in same direction with same magnitude. So therefore, if I draw the graph of current with respect to time, then magnitude of current will be like this. What do you understand by this graph? స్ట్రైట్ లైన్ వేసినాడు సార్, అంతే. ఇంకా మాకేం అర్థం కాలేదు. ఏం అర్థమైందో చెప్పండి. సో విత్ రెస్పెక్ట్ టు టైమ్ కరెంట్ ఈస్ ఏ కాన్స్టెంట్. దిస్ ఈస్ వాట్ వీ అండర్స్టాండ్. క్లియర్ నమ్మా? సో దిస్ ఈజ్ పాసిబుల్ ఇన్ డైరెక్ట్ కరెంట్ ఇఫ్ ఐ సప్లై ఏ డీసీ సోర్స్ ఆఫ్ పొటెన్షియల్ డిఫరెన్స్. డీసీ సోర్స్, బ్యాటరీ ఈస్ ఏ డీసీ సోర్స్ను బ్యాటరీస్ కనెక్షన్ చేస్తాం కదా. సో ఫ్రమ్ దేర్ వీ విల్ గెట్ డైరెక్ట్ కరెంట్. అండ్ కరెంట్ ఈజ్ ఆల్వేస్ ఇన్ ద సేమ్ డైరెక్షన్ and magnitude of current is also same. That is called as DC current. Clear, ma? But the supply which we are getting to our houses, this is not DC. This is AC. Are you able to understand? So therefore, in the same resistor fan is a resistor. So to this resistor, if I supply this kind of voltage, what is the symbol of this one? This is AC symbol, alternating current. This is a DC symbol, direct current. Are you able to understand, ma? Then the type of current or the magnitude of current and direction of current which I get is, I will get this kind of current. Okay. Now when you look at this graph, what do you understand? ఏమర్థమవుతుందిరా? పాంపిల్ అనేస్తున్నాడు ఒకటి సారు. వేవ్ లైక్ మోషన్ అంటే కరెంట్ పైకి కిందికి ఎగిరి దూకుతా ఉందా? ఏం చేస్తూ ఉంది అక్కడ? First of all, current has become maximum, no? I0. Current has increased from 0 to maximum. From there it decreased from maximum to 0. Now current started flowing in opposite direction also, minus I0 also. This is what I understand, no? So this is the same type of current which we are getting in our houses. Okay, ma? So first strength of current increases, strength of current decreases, then current flows in opposite direction. Then it reaches to maximum in negative direction, then again it becomes 0. This is the type of current which is called as AC, alternating current. Okay, see ma. In AC, actually what is happening, let us see. Consider this is a wire, ma. This is a wire in which current is flowing. Okay. Now we have given an AC source, a source of alternating current. So if I check this cross section, I am taking a small cross section on this wire. So cross section. Are you able to understand, ma? So then I see that in this direction, first of all, one electron will flow. Okay, ma? I am checking some cross section in a wire and I am counting how many electrons are flowing in 1 second. And what is the source I have given? I have given AC source. Then I see that initially one current will flow. Then 2 electrons will flow, then 3 electrons will flow, then 4 electrons will flow, then I see 5 electrons will flow. Okay. So what is happening to the strength of current? Increasing, no? Then I also observe that then afterwards 4 electrons will flow, then followed by 3 electrons, then 2 electrons, then 1 electron, and finally 0. Okay, this is what I see. Okay, ma? Then after again I will see that now current is flowing in opposite direction. Now 1 electron will flow in opposite direction, 2 electrons, 3 electrons, 4 electrons, 5 electrons, then again 4 electrons, 3 electrons, 2 electrons, 1 electron, finally 0. Okay. So this is how the passage of electrons will be there in our wires. మన వైర్స్లో ఇలా జరుగుతూ ఉంటుంది. అర్థమవుతుంది కదా? సో కంటిన్యూస్లీ ఒకే డైరెక్షన్లో కరెంట్ పాస్ అవ్వదు. Current is not passing in the same direction with same magnitude. So, see the strength of current, it is slowly increasing. Then in the same direction, it decreases also. Okay? Now current starts flowing in opposite direction and it increases also. Now in the same opposite direction, again it will decrease also. So this type of current we can call it as alternating current, whose magnitude and direction they change continuously. Are you able to understand? So write down. So therefore, how can I define AC? AC, how can I define ma? It is that type of current. It is that current whose magnitude changes continuously, and direction reverses periodically. Okay, ma? Magnitude will change continuously and periodically direction also will change. That is called as AC. So there are many types of ACs, ma. Here we are studying only sinusoidal AC. There are many kinds of AC. So this is also an AC. Okay. So I can say this is also an AC. Triangular AC. Clear, ma? I can say this is also an AC. Okay. There are many kinds of ACs. Now in our syllabus, we are studying only this AC, which is called as sinusoidal AC. Sinusoidal AC. It is in the form of sine curve, no? So it is called as sinusoidal AC. Sinusoidal alternating source of current. Clear? Now see. So how can I write equation of this AC? That we will see. Clear, ma? So, equations. For sinusoidal AC, the equation of EMF, is E is equals to E naught sine omega t. Okay, ma? And the type of AC will be like this. This is the type of AC. Same equation I can write like this also. E is equals to E naught cos omega t also I can write. But the type of AC will be like this. Okay. So these are the equations for representing alternating source of potential difference in the circuit. Are you able to understand? Sima, what is the meaning of it? Meaning we need not understand, because same type of equations you will study in simple harmonic motion also. Okay? Study these equations in SHM, then you will understand why we have written equations like this. Clear, ma? We are not discussing this one in much detail. So if I start from 0, or if strength of current is increasing from 0, then the equation is E is equals to E naught sine omega t. And at 0, already if the supply EMF is maximum, then the equation is E is equals to E naught cos omega t. Are you able to understand? Okay. Similarly, equation of current, how can I write? So these are the equations of EMF, supply voltage which we have given. And equation of current, how can I write? Equation of current is, okay, I is equals to I naught sine omega t. Okay, this is the equation of current. So where E naught and I naught, they are maximum values. What is meant by E naught and I naught, ma? Maximum values. Whereas E and I, they are instantaneous values. So what is E comma I? Instantaneous values. Are you able to understand? Instantaneous values means what? Values at a particular instant. Okay, we will try to understand by taking a small example, ma. See here. చూడండి మా ఇది. సో E is equals to E naught sin omega t. Let us try to analyze this one. What is meant by omega? Angular frequency. Angular frequency. So omega can be written as 2 pi by capital T also. It can be written as 2 pi f also. Clear? What is meant by capital T here? Time period. Time period. Okay, ma? So let us write a case. Case is that let time period is equal to 4 seconds. What is the case we are taking, ma? Case is time period is equal to 4 seconds. What is the meaning of this? Time period is 4 seconds means what? Time period 4 seconds ante emani? Time taken for one oscillation to complete. That is called as time period, no? It means this is one complete oscillation, no ma? Time taken for this oscillation to pass this point is called as time period. Okay? Now let us divide this one. So if this is one wave, if I compare this one with a wave, then from here to here time taken will be 1 second. Up to here time taken will be 2 seconds. Up to here time taken will be 3 seconds. And for this complete wave to be completed, total time taken is equal to 4 seconds. Are you able to understand? So I am taking time period is how much? 4 seconds. That is time taken to complete one oscillation. I will call it as 4 seconds. Now I want to find E value at t is equal to 1 second. Okay, ma? What is meant by small t? Small t means instant of time. Capital T means total time period. Total time period is 4 seconds. Now at a time of 1 second, after I started observing this wave, after 1 second I want to find out what is the EMF of this particular supply. Are you able to understand? So just take these values and substitute in this equation. See what we will get. So E is equals to E naught sin. Instead of omega, I can write 2 pi by capital T multiplied by small t. I can write like this also, no? Instead of omega, I can write 2 pi by capital T. Instant of time is already present, no? Substitute these values. So E is equals to E naught sin, clear, ma? 2 pi by capital T is 4 seconds multiplied by instant of time is 1 second. 2 pi by 4 is how much? Pi by 2. So therefore it is E naught sin pi by 2. Sin pi by 2? 90 degrees. Sin 90? 1. 1 into E naught? E naught. So therefore at t is equal to 1 second, I got instantaneous value of EMF is equals to E naught. And what is meant by E naught? Maximum value. See if it is satisfied or not. We start our counting from here. After 1 second, what is the maximum value of EMF? E naught. Satisfied? No? So that is why we write equations like this. అర్థమవుతున్న ఈక్వేషన్స్ ఇలా ఎందుకు రాసినాము? క్లియర్ మా? E naught is maximum value. E is the instantaneous value. ఆ పర్టికులర్ సెకండ్లో దానికి ఎంత వాల్యూ ఉంది? దట్ ఈస్ కాల్డ్ as instantaneous value. Value at a particular instant of time. Are you able to understand? That's it. Okay, ma? Similarly, same equation I can use for current also. I is equals to I naught sin omega t. Right. See, ma. So next concept which you are studying is mean value or average value of EMF and current. Okay, ma? See, ma, for this complete cycle, can you say what will be the average value of current or what will be the average value of EMF? Anybody? For complete cycle. Okay, ma? E average, or you can write E mean value will be how much? ఎంత ఉంటుంది చెప్పండి? చెప్పండి. हाफ का चाहिए. Zero. This is positive half cycle, this is negative half cycle. ఇప్పుడే కదా బ్రహ్మాండంగా ఎలక్ట్రాన్ డయాగ్రామ్ కూడా వేసినాను నేను. So how many electrons are crossing in first half cycle? Same number of electrons are returning back also through the same cross section. So for the complete cycle, if I take average value indicates the amount of charge which is passing. Average value indicates what? Amount of charge which is crossing through a cross section. So for one complete cycle, it will become 0. So I value, I average or I mean also will become how much? 0. So I average, current passed R, E average will also become 0. Okay. So therefore what I do, I will try to take E value or I value only for half cycle. But for half cycle it is not 0, no? Half cycle indicates only charge flowing in only one direction. That cannot become 0. Are you able to understand, ma? So therefore for half cycle, E mean or E average, or just you can write EM. So in ఒక్కొక్క బుక్లో ఒక్కొక్క విధంగా ఉంటుంది. సో ఐఎమ్ రైటింగ్ ఆల్ ద ఇండికేషన్స్ హియర్. సో దిస్ ఈజ్ ఈక్వల్స్ టు 2/π times of E naught, or you can write it is 0.637 times of E naught. So this value is called as mean value for half cycle. Okay. So it has how many times of E naught? 2/π times of E naught. And what is E naught? Maximum value of EMF. Okay, 2/π if you convert, it converts into 0.637. So 0.637 times of maximum value of EMF, that is called as average value of EMF, or you can call it as mean value. Okay. Similarly, I can write current also. I mean or I average or just IM is equals to 2/π times of I naught, which is equals to 0.637 times of I naught. That is our answer. Clear, ma? So next we study about RMS value. Right now. Okay. So average value we have studied. Now we are studying about RMS value. What is meant by RMS value? It is a measure of heat produced in the circuit and it does not depend upon direction of charge. What is the meaning of this one? In average value, what we have studied? In average value, we have studied how much charge is flowing. No? How much charge is flowing, that we have studied. But charge can be cancelled also, because in first half it flows in one direction. Second half it flows in opposite direction. So charge can be cancelled also. But here RMS value is the amount of heat produced. See, for example, if it is a wire and if this is the cross section, are you able to understand? So if a charge flows in this direction, then heat will be produced. No? If a charge flows in opposite direction, then also heat will be produced. Are you able to understand? Charge etu poyina heat aithe produce avutundi kada. Are you able to understand, ma? If charge is flowing in one direction, heat will be produced. Charge flows in opposite direction, then also heat will be produced, because electrons always collide with the atoms and heat will be produced. So therefore, to measure the amount of EMF or amount of current, RMS value is an effective measure of measuring the values. Okay. Now what is the definition of RMS value? It is that value of DC. It is that value of DC that produces the same amount of heat as produced by AC in the same time and in the same circuit. This is called as RMS value. ఏం అర్థమైంది చెప్పండి? RMS value is what? It is that value of DC which produces the same amount of heat as produced by AC in the same time and in the same circuit. ఏం అర్థం? Point is that, see, my AC is continuously changing, no? How AC changes? Magnitude of AC continuously changes. So we cannot give a particular value to this one. So at some time it is maximum, then it is 0. Again it goes to another maximum. So here I cannot have a measurement. So what I do is I will try to convert AC in terms of DC. DC is direct current, no? DC means how current flows in DC. This is DC. Current flows in same direction, with same value also. So AC I will try to convert in terms of DC, so that I can have a particular value of how much heat can be produced. Okay, ma? So I will take the same value of AC, which can produce the same amount of heat as can be produced by DC. So AC I am trying to convert into DC. That's it. Are you able to understand? And the values are like this. So ERMS value is how much? E naught divided by root 2. Root 2 can be written as 0.707 also. And IRMS, I naught divided by root 2. So 0.707 I naught. These are the RMS values. Okay? Right. See this question. So this is the equation of AC which is given. I is equals to 141.4 sin 314t. Okay? And he is asking us to find out 1, 2, 3, 4 values, maximum value. How can I calculate maximum value? Chappandi. Compare this one with the actual equation. Comparing with, what is the equation of current? I is equals to I naught sin omega t. This is the equation, no? What is meant by I naught here? Maximum value. So maximum value is nothing but 141.4. That's it. Are you able to understand, ma? So therefore, I max, maximum value of current, which is equals to I naught, is equals to 141.4 amperes. That's it. Are you able to understand? Just we are comparing with original equation. That's it. Now, second question. Frequency. Okay. Frequency, how can I compare, ma? See. Omega can be written as 314, no? Here I have sin 314t. Here I have omega t. Omega is nothing but 314. So, omega is 314. Omega can be written as 2 pi f. 2 pi f is equals to 314. So, therefore, frequency is how much? 314 divided by 2 pi. Clear, no? So, 314 divided by 2 into 3.14. So, therefore, it is how much? 100 divided by 2. It is equal to 50 hertz. So, that is the frequency of this EMF. Are you able to understand? Now, what is the third question he is asking? Time period. Can you say how can I calculate time period? Anta length gaakunda chinnaga chupra. Time period is nothing but reciprocal of frequency, no? What is time period? Reciprocal of frequency. Clear, no? So 1 by 50. 1 by 50 seconds is the time period. Are you able to understand? Fourth one is instantaneous value. So first of all, write this, then we will solve. Now see the fourth one. What is the fourth one he is asking? Fourth one is instantaneous value of current. It means I is equals to I naught sin omega t. What is the equation given? I is equals to 141.4 sin 314 multiplied by time taken is how much? Time taken is 3 into 10 power minus 3 seconds. Okay. So just do this calculation. That will be the value of instantaneous value of current. Clear, no? So answer which you should get is 114.35 angstroms. Sorry, amperes. Okay. 114. This much amount of current will flow at what time? At a time of 2 into 10 power minus 3 seconds. Are you able to understand? See, when this time changes, current also changes, because all these are instantaneous values. No? At this instant of time, this much amount of current is flowing. That is the meaning of it. Right. Student 1. See, here, what is the given question? An AC voltmeter records 50 volts. Clear, ma? Across a sinusoidal power source of frequency 50 hertz. Then you are supposed to write equation of instantaneous voltage provided by the source. That is the question. Clear? See, here AC voltmeter, one point which you should understand is that AC voltmeter always records RMS values only. Okay? AC voltmeter can measure what? AC voltmeter can measure only RMS values only. It means it is measuring 50 volts, no? 50 volts means what is that? That is RMS value of voltage. Clear? So therefore, ERMS is how much? ERMS is 50 volts. One information we got, no? And what is the frequency of this source? Frequency of this source is 50 hertz. Now we were supposed to write down the instantaneous value of voltage. What is the instantaneous value of voltage? E is equals to E naught sine omega t. That's all, no? So therefore, I will write here. So E is equals to E naught sine omega can be written as 2 pi f multiplied by t. I can write like this, no? Frequency is already given. Frequency is 50. Okay. E naught value, is it given? E naught value ఇచ్చినాడు మరలా దాని నుంచి అది ఎలా ఫైండ్ అవుట్ చేస్తాం? Relation already we have, no? Sima, what is the relation of ERMS? ERMS is equals to E naught divided by root 2. Already we have written equation, no? RMS value of EMS is 1 by root 2 times of maximum value of EMF. And in this equation I have E naught, but ERMS is given. So find out E naught. E naught value is how much? ERMS multiplied by root 2. ERMS is how much? 50. So 50 root 2 is my maximum value of EMF. So substitute. Therefore what I can write? E is equals to, so 50 root 2 sine. Okay, ma? Now see, frequency is 50. 52s are 100. 100 into 3.14? 314. So 314 t. This is my equation of instantaneous value of EMF. Instantaneous source of EMF. Clear? See here. So now we are studying about AC circuits. Ma? The first circuit which we are studying is circuit containing only resistance only. So in this circuit only resistance is placed and we are giving this alternating source of EMF. Are you able to understand? So therefore now I want to find out an equation of current. So we know that I is equals to V by R, no, by using Ohm's law. What is V here? V means what? Huh? Supply potential. This is the supply potential, no? E ante ikkada electric field gaadu ikkada confuse ayyar meeru. E is not electric field. E is potential difference, V only. Are you able to understand, ma? So V value is how much? V value is E naught sine omega t divided by R. Okay. So therefore I value how much I got? E naught by R sine omega t. Okay, ma? This is the equation of current which I got. Okay. So in all the circuits what we will do? In all the circuits we will take supply voltage and we will try to derive equation of current. ఇదే చేస్తాం మొత్తం ప్రాసెస్. ఓకేమా? వాట్ ఈస్ ద సప్లై వోల్టేజ్? ఈ నాట్ సైన్ ఒమేగా టీ. వాట్ ఈస్ ద కరెంట్ ఐ గాట్? ఈ నాట్ బై ఆర్ సైన్ ఒమేగా టీ. సో వెన్ ఐ లుక్ అట్ ఫస్ట్ ఈక్వేషన్ అండ్ సెకండ్ ఈక్వేషన్, వాట్ డూ ఐ అండర్స్టాండ్? వెన్ ఐ లుక్ అట్ ఈక్వేషన్ ఆఫ్ వోల్టేజ్ అండ్ ఈక్వేషన్ ఆఫ్ కరెంట్, నాకేం అర్థమవుతుంది చెప్పండి? బై సీయింగ్ బోత్ ఈక్వేషన్స్, okay ma, we see that current and voltage are in phase. Current and voltage, they are in phase. In phase means what? There is no phase difference between them. వాటి మధ్యలో phase difference లేదు. So how can I draw line diagrams? Phasor diagrams, how can I draw? Phasor diagram indicates phase ma. So for example, if it is V RMS, then it is I RMS. This is how I can draw. What do you understand by this? Voltage and current, they are in the same phase. This is what we understand. Are you able to understand? And if I draw a graphical representation, I can draw like this also. Clear now? So consider this is voltage. This is what? This is E. And Sima here, one point which you can see here is, what is the maximum value of E naught? What is the maximum value of EMF E naught? No? What is the maximum value of current? E naught by R. It means current magnitude will be definitely less than voltage magnitude. So therefore, graphically, how can I draw? I can draw like this. Are you able to understand? Dotted line indicates what? Dotted line indicates instantaneous values of current. But they are in the same phase. Phase difference లేదు చూడండి. Are you able to understand? This is one point which you should understand. When only resistor is present in the circuit. So when only resistor is present, there is no phase difference. Are you able to understand? Next we study about power consumed by the resistive circuit. Okay, ma? First of all, we will write resistance. What is the equation of current actually? I is equals to I naught sine omega t. But what is the equation we got? I got E naught by R sine omega t. This was the equation which I got, no? So if you compare both equations, I will get I naught is equals to E naught divided by R. By Ohm's law, what is meant by R? R is called as resistance of the circuit. I is equal to V by R. So R is called resistance of the circuit. Are you able to understand? So now if I study about energy consumed by resistor. Energy consumed by resistor. Resistor will consume how much energy? Then the equation is, or instead of energy, I will do one thing. I will write power consumed by resistor. So power consumed by resistor is equals to ERMS multiplied by IRMS is one equation. IRMS square multiplied by R, this is another equation. ERMS square divided by R, this is another equation. So these are the three equations of power consumed by the resistor. Anyone you can use according to your necessity. Okay? అవసరాన్ని బట్టి ఏది పడితే అది విచ్చలవిడిగా మీరు వాడుకోవచ్చు. Clear? That's it. So therefore, in resistive circuit, what is the point you should understand is that in resistive circuit, current and potential difference, they are in phase. Both of them, they are in the same phase. There is no phase difference. That is the point which you should understand. Clear? Right now. Sima, listen. So now we are studying the circuit which consists of only inductor only. Resistance is not present. Capacitance also it is not present. Clear? Now we are writing the equation of supply voltage. I want to derive equation of current. Okay? Sima. So induced EMF by inductor. Okay, ma? First of all, why this inductor will induce EMF, ma? Can you say? If I supply this source of EMF, this inductor also will supply a back EMF. What is the reason? Japan. Yesterday only we studied in electromagnetic induction. Inductor also will induce an EMF. We are supplying an EMF. Inductor also induces an EMF. Why? What it doesn't want to increase? Current. Very good. That is Lenz's law. No? Are you able to understand? Sima, EMF is variable, no? EMF constant or variable? Huh? This is variable. So current is also variable. If current is variable, flux is also variable. If flux is variable, flux linking with inductor is also variable. And if flux is variable, definitely EMF will be produced. So therefore, this inductor, what it will do? It will develop an EMF of EMF is equals to minus L di divided by dt. Already we have written equation in the last class, no? Minus L di divided by dt. And this EMF will oppose this EMF supplied by the battery or supplied by the source. That is the function of Lenz's law, no? It always opposes. But what battery again will do? Battery will supply again potential in opposite direction. So potential supplied by battery is how much this time? Minus L di divided by dt. ఇది అపోజ్ చేస్తుంది కదా, ఇది వదిలేదు కదా. It will definitely again, it will oppose the EMF induced by the inductor, and this much amount of opposite EMF is again given by battery. Minus అంటే అర్థం అవుతుంది కదా. This minus indicates the EMF induced by inductor. One more minus indicates again the forcefully EMF given by the source. Clear? So therefore, what is the final EMF which is developed? E is equals to minus of minus plus L di divided by dt. Clear now? So from this I want equation of current. So E by L dt is equal to di. Therefore di is equals to, E means instantaneous value of EMF, and what is the equation of instantaneous value? E naught sin omega t. So E naught sin omega t multiplied by dt divided by L. This is the small amount of current. If I want total current, integrate it on both sides. So integration of di is equals to integration of E naught by L sin omega t dt. Integration and differentiation will get cancelled. I is equals to integration of E naught by L sin omega t multiplied by dt. Now here, who are the constants, who are the variables? E naught by L is a constant. E naught is maximum value of EMF, constant. Inductance is also a constant. Sin omega t is a variable because t changes continuously, no? It is a variable. So take the constants out of integration. So E naught by L integration of sin omega t dt. Integration of sin omega t minus cos omega t minus cos omega t. Okay, ma? And omega t I have not differentiated, no? Sorry, omega naught I have not integrated. I have integrated only sin. Now if I integrate to omega t also, I will write a differentiation of omega t. Differentiation of omega t is omega. This is how we do the chain process of integration. Are you able to understand, ma? So therefore, what is the final answer I got? I got E naught divided by omega L multiplied by minus cos omega t. Okay. So minus cos omega t can also be written as sin omega t minus pi by 2. I can write like this also. Okay, ma? So this is the final equation of current which I got if only inductor is present in the circuit. Are you able to understand, ma? So all these are trigonometric rules. I hope you understand. Minus cos omega t can be written as sin omega t minus 90 degrees. Sin omega t minus pi by 2. Are you able to understand? Now see. So now which is my first equation? Supply voltage is my first equation. Current equation is my second equation. Okay. Compare 1 and 2. What do you understand? There is a phase difference of how much? Pi by 2. Which one is leading? Which one is lagging? Tappandi. Current value is lagging by 90 degrees, no? So current lags voltage by 90 degrees. That is what we understand. Clear, Nama? Therefore, observing equation 1 and equation 2. Okay. So observing first equation and second equation, we see current lags voltage by 90 degrees. This is what we understand. See here, omega t minus pi by 2. Minus pi by 2 means what? Current is lagging. It means first potential difference will develop. After 90 degrees, current will reach the maximum value. That is the meaning of it. Are you able to understand, no? Therefore, if I draw phasor diagram, how can I draw? Phasor diagram if I draw, clear, ma? Then I should draw like this, no? If it is IRMS, then this one should be ERMS. And this phase lag should be 90 degrees. Are you able to understand, ma? See here, which one is lagging, which one? Chappandi. Current is lagging potential difference by 90 degrees. Previously in resistor, how we have drawn? Both of them, they were in the same direction, no? In resistance, current and potential difference were in the same direction, same phase, no phase difference. But here there is a phase difference of 90 degrees. Are you able to understand, ma? So this is IRMS and this is ERMS. Fine. Now phasor diagram, how can I draw? Sorry, phasor diagram already we have drawn, no? Graphical representation, how we can do? రాస్తా ఉన్నారా? రబ్ చేసేస్తా ఉన్నాను. రాస్తా ఉన్నారు కదా. Okay, ma. Phasor diagram I can draw like this. It should lag, no? Current should lag. This one. Okay. So this is E, instantaneous value of EMF. This is I, instantaneous value of current. Can you say why I have drawn the graph like this? Anybody? See, my first EMF is reaching maximum value, no? After 90 degrees, current is reaching the maximum value. Okay? Here what is the phase? This is 0. This is 90. This is 180. This is 270. This is 360. Okay, ma? So at 90 degrees, voltage has reached maximum. Then at 180 degrees, current has reached maximum. It means current is lagging voltage by 90 degrees. That is how we draw the phasor diagrams. అర్థమవుతుంది కదా ఎలా వేస్తున్నాము? ఓకే. నెక్స్ట్ లెట్ us write the equations what we got. So inductive reactance. Next concept which we are studying is inductive reactance. In general terms, we say that resistance offered by inductor. Okay, ma? Actually, inductor doesn't consume energy, but it will delay the rise of current or fall of current. So it also gives some resistance. So that resistance offered by the inductor is called as inductive reactance, given by XL. Okay, ma? Now to calculate this one, we should write the equations of voltage and current, ma. So I is equals to I naught sin omega t. Now what is the equation we got? మనకు వచ్చిన ఈక్వేషన్ ఇది I is equals to E naught divided by omega L sin omega t minus pi by 2. This is the equation we got, no? Are you able to understand, ma? Now if you compare both these equations, what we understand? If I compare these two equations, I can say I naught is equals to E naught divided by omega L. This is what I get, no? Are you able to understand, ma? Now this is just I is equal to V by R. This is of the form, which form? I is equal to V by R. Okay? So I can write E naught divided by XL. Now what is XL? XL is nothing but omega L. Or you can write 2 pi f L. Okay, ma? So this XL is called as resistance offered by the inductor. అర్థమవుతుందా ఏమన్నా? This is the equation which I got, no, ma? This equation I am comparing with Ohm's law. What is Ohm's law? I is equal to V by R. So resistance should be how much? Omega L. That resistance offered by the inductor is called XL. So XL is omega L. Omega value 2 pi f. So 2 pi f L. Are you able to understand? See, one point which I can see here is XL is directly proportional to frequency, no? XL is directly proportional to frequency. So if frequency of source increases, resistance offered by the inductor also increases. Clear? So what is the note point I can write? Note point is that if frequency of source increases, clear, ma? Then inductive reactance also increases. Inductive reactance also increases. Clear? Next, power consumed by inductor. Power consumed by inductor. Power consumed by inductor is 0. Average power consumed by inductor is how much? 0. Inductor never consumes any power. Resistance consumes power. Inductor and capacitor, they will not consume power. They will store energy for some time, then they will release energy. Store for 1/4 of cycle, release in the next 1/4 of the cycle. That's it. Clear now? So therefore what I write? Inductor does not consume power. Inductor does not consume power. Evarni? Osi annaku? Okay. See, next we are studying about AC circuit containing only capacitance only. Okay, ba? So what is the supply voltage we are giving? Again, same concept everywhere. We will write equation of EMF and we will try to derive equation of current. Everywhere same concept. Okay. Now see here, what is the equation of capacitance? C is equals to Q by V. Okay. Or I can write V is equals to Q by C. V is nothing but supply voltage. V can be written as E naught sin omega t is equal to Q by C. Okay. So therefore Q, how can I write? Q can be written as C E naught sin omega t. I can write like this also. So I got equation up to here. Okay, ma? Now from this one, how can I calculate current? Current ane padame kanipiyadam ledhu ikkada. Etla cheddam mari? See, we know that I is equals to dq by dt, no? I is equals to dq by dt. So if you differentiate this one with respect to time, that is current. Are you able to understand? No? So I is equals to d by dt of C E naught sin omega t. That's it. Differentiate cheyandi mari. In inductor we have integrated, no? Now here we are differentiating. Okay. Your missed call. Okay, ma'am. So yesterday we studied 3 circuits, nama. Circuit containing only resistance, only inductance and only capacitance. This is what we studied, no? Now what we are studying combinations. Clear? So in a series circuit, resistance and inductor both are present. Are you able to understand? Resistance is also present, inductance is also present. Now from this one, I want to analyze the circuits, what is the power consumed, what is the phasor diagrams, all this we have to study. Are you able to understand? Now let us see. So for example, if I take resistor, how did we draw the phasor diagrams in resistor? Do you remember? Resistor lo phasor diagrams ela vesam. Notes dekho ji. Resistor, circuit containing only resistor. How did we draw the phasor diagrams? Same. So it means that if it is VR, what is meant by VR? Voltage consumed by resistor. Then IRMS is also in the same direction. This is what we have written. It means there is no phase difference between voltage and current. Ide kada ninna manamu analyze chesindi. So this concept should be very clear. In which circuit, what is the phase angle between current and voltage? This is very important. Are you able to understand? Similarly, the second component is inductor, no? Inductor. Now in inductor, what is 90 degrees? Who is lagging, who is leading? Current lagging, voltage is leading. So therefore, how can I draw the diagrams? If it is IRMS, definitely I can say this is VL. What is VL? Voltage drop in inductor. Are you able to understand, ma? So in the case of inductor, voltage leads current by 90 degrees. Voltage leads current by 90 degrees. Okay. Now here resistor and inductor, both of them, they are connected in series, no, ma? So therefore, I want to club these 4 phasors. How many phasors are there here? 1, 2, 3, 4. 4 phasors are there. Combine these 4 phasors and draw a single diagram. Single phasor diagram. How can you draw? Chepandi. I want to combine all of them and draw a single diagram. How it is possible? Same diagrams only, by using same directions, all of them I want to represent in a single diagram. Why? Because both components, they are present in series, no? How can you draw? See, here IRMS is common, no? Here VR, this is the voltage drop in resistor, voltage drop in inductor. Current is same in both of them, no? See, for example, if current produced is IRMS in the circuit, how much current will flow through resistor? IRMS. How much current will flow through capacitor? IRMS only, because both of them, they are in series, no? So therefore, potential drops may be different. Their phasor diagrams, angles also may be different, but current flowing in them is same. So what is the note point here? We have to write note point is that current through both components is same. Current through both components is the same. Are you able to understand? So therefore, how can I combine them? Combining all the phasors. Combining all the phasors. How can I combine them? So this is VR. This is IRMS. Next, this one is VL. I can combine like this. Okay, ma? 4 phasors are converted into 3 phasors because one phasor is common. IRMS is common, no, for both of them. So this is how I can draw. Clear? Now this is the voltage drop across resistor and this is the voltage drop across inductor. Now, if you take the resultant of these two, then it is called as ERMS. ERMS. What is ERMS? That is the total potential consumed in the circuit. Okay, ma? That is the resultant, no? So this is potential drop across resistor, potential drop across inductor. Okay? So both the vectors, they are joined head to tail. Resultant should be head to head and tail to tail. Triangle rule of addition. So therefore, ERMS, how can I write? ERMS is equals to square root of VR square plus VL square. I can write like this. Is it clear? So therefore, this is the supply potential we have to supply. Supply potential to be supplied. Or just you can say potential to be supplied. Are you able to understand how we got this one? Okay. Now see. Now, ERMS, how I can write? ERMS can be written as IRMS multiplied by Z. I can write like this. Clear, no? What is Ohm's law? V is equal to I into R only, no? So I into R. But what is this R here? This is called as impedance. Impedance of the circuit. Impedance means combined resistance of the circuit. So here resistance is given by resistor also. And inductor has inductive reactance, no? That is also a type of resistance. So both resistance combined together, it is called as impedance. The total resistance of the circuit. Clear, no? So this is equals to square root of, can you say how can I write VR? VR. According to Ohm's law, VR ni ela rayachu. What is VR? What is VR? Potential drop in resistor. How can I draw? Z into? Z kai ko aata hai ji? Circuit ka total resistance Z. What is the resistance of resistor? I into R, that's all. So therefore, according to Ohm's law, IRMS multiplied by resistance of resistor is R only. So IRMS into R whole square. Clear, Nama? Similarly, VL, how can I write? I into L. Abba. Inka. I into IRMS multiplied by XL, Nama. This is what we have written, no? What is the resistance of inductor? XL. It is not L. L ante inductance. XL means inductive reactance. Are you able to understand, ma? So therefore, IRMS, if I get cancelled, then what is the answer I will get? Z is equals to square root of R square plus XL square. Okay, ma? So this is the equation to calculate impedance of the circuit. Is it clear? So this is how we calculate impedance, the combined resistance of the circuit. So what is meant by Z here? Z is nothing but impedance. Impedance of circuit. Or you can call it as combined resistance of the circuit. Understood, Amma, what is happening? Combined resistance of the circuit is called impedance. Okay. Now we will study the phasor diagrams now. See here. Shall I rub this? This side completed now? Now see. See ma here, this is the current which is flowing in the circuit, and this is the RMS value of voltage which you should give. ERMS is combined voltage, no? Resultant voltage which you are supposed to supply. Now can you say in this circuit, current is leading or potential difference is leading? Which one is leading? Chappandra. Current is leading or voltage is leading? Voltage is leading. ఇది పడుకొని ఉంది, ఇది కొంచెం లేచుంది. ఖచ్చితంగా ఇదే కదా లీడింగ్ అక్కడ. ఏముంది అంతగా ఆలోచించడానికి? ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? సో హియర్ ఐ కెన్ సే పై. ఓకే మా? సో ఇన్ ద కేస్ ఆఫ్ విచ్ సర్క్యూట్? ఇండక్టివ్ సర్క్యూట్. ఇండక్టెన్స్ ఉంది కాబట్టి అది ఇండక్టివ్ సర్క్యూట్ అంటాం. ఇన్ ద కేస్ ఆఫ్ ఇండక్టివ్ సర్క్యూట్, వోల్టేజ్ లీడ్స్ కరెంట్ బై పై వాల్యూ. Are you able to understand? Or just you can draw, if you draw the phasor diagrams I and ERMS. So this is IRMS, this is ERMS. So this is angle pi. So definitely what I can say, in inductive circuit, resistance is also present, but inductance is also there, no? Therefore you call it as inductive circuit. In inductive circuit, clear ma? Voltage leads current. Voltage leads current by pi or theta, anything you can write. Are you able to understand? So therefore, by using this one, what I will do, I will draw impedance triangle. Okay ma? So impedance triangle. What is impedance triangle? See here. So just you take all the voltages here. This is VR, this is VL, and this is ERMS. Clear now? So I got a right angle triangle now here. Now this VR can be written as I into R. VL can be written as I into XL. ERMS can be written as I into Z. This is how I can write now. This is the resistance of resistor. This is the resistance of inductor. Z is the resistance of total circuit. Satisfied? No? Now from this one, you remove all the I values. I is common in everything, no? I. Remove all the I values. If you remove all the I values, then I will get a triangle which is called as impedance triangle. And what will be the shape of this triangle? It will be like this. So this is Z, this is R, and this is XL. Okay? So triangle in which only resistance are identified. All resistance we have drawn. So that is why it is called as impedance triangle. Are you able to understand? No? Completed this side? Now see. So therefore in this impedance triangle also, I can indicate the same value of pi. Okay? And here I will write a term called cos pi, which is called as power factor of circuit. Power factor of circuit. Cos pi is called as power factor. Now by looking at this triangle, can you say cos pi is how much? R by Z. That's all, no? Adjacent by hypotenuse. Huh? So cos pi is nothing but R divided by Z. Are you able to understand, ma? So what is the importance of cos pi? If cos pi value is maximum, the energy which you are supplying, it will be utilized by maximum also. That is, the efficiency of the circuit will increase if cos pi value is maximum. That is the importance of it. So let us write the importance of power factor. Importance of power factor. Okay, ma? So if cos pi is maximum, then efficiency of the circuit will be maximum. Then efficiency of circuit is maximum. Okay, ma? Now can you say what is the maximum value of cos pi? Cos pi ki unde maximum value enta? 90. Angle gadra ani adutannedi cos pi value. Cos 90 sunna ka subakka. Adi maximum aitadre. 1. Cos pi can have maximum value of 1. That's it. Cos 0 is 1. Beyond 1, cos pi value cannot go. For sin theta and cos theta, maximum values are only +1 and -1 only. Beyond that, they cannot go. Clear, ma? So therefore, cos pi maximum value is how much? 1. And cos pi will become 1 when theta is equal to 0 degrees. So therefore, pi value is 0. If pi value is 0, then which value will become 0, ma? In this triangle, if pi value should become 0, then cos pi is maximum. If cos pi is maximum, power factor is maximum. If power factor is maximum, efficiency of the circuit is maximum. Are you able to understand? So if cos pi should become 0, how this triangle should change? XL should become 0. That's all, no? Are you able to understand, ma? So if pi value should become 0, this line should start coming like this, no? Ila raavadam start avutadi. Kindiki raavadam start avutadi. It means XL value reduces and finally it will become 0. Are you able to understand? It means that if resistance offered by inductor is 0, then power factor is maximum. That is the point which we should understand. Are you able to understand, ma? So therefore what I write? Therefore, if not only XL, VL or XL is 0, then power factor is maximum. Then in that condition, power factor will be maximum. Are you able to understand, ma? That is the importance of power factor. Is it clear? Now, if I draw the what you call graphical representation of current and voltage, how can I draw? Graph of ERMS and IRMS. How can I draw? Okay. See, ma'am. So this is ERMS, the supply voltage. Now can you say how can I draw IRMS? Anybody? IRMS ni ela draw cheyali? Cheppandi. So in the case of inductive circuit, current is leading voltage or voltage is leading current? Voltage is leading current, no? So in the diagram also I should represent like that only. Are you able to understand, ma? How can I draw? I can draw like this. Clear, ma? So this is ERMS and this is IRMS. So by this diagram, how can you say that current is lagging voltage? Ela cheptaru? Ela cheptaru? Aithe inko vidhanga ela cheptaru? See, first ERMS has reached maximum, no? First ERMS value has reached maximum, then it is followed by maximum value of current. So definitely there is some phase difference, no? Are you able to understand? First, which one is reaching maximum? Voltage. Then followed by current. It means current is leading, lagging voltage. This is how you can represent. Understood, no? Okay. Now by using the same concept, I will write power triangle. Okay, ma? Power triangle. So all of them we are studying in RL circuit only. All these concepts we are studying in RL circuit. See, what is power triangle? See, we know that if this is IRMS, then this is ERMS, no? Are you able to understand me? So in the case of RL circuit, voltage is leading current by small angle of pi. Okay? So what I do is, I will try to split this IRMS into two components. How can I split? Okay. I can split like this, no? So this is IRMS cos pi, and this one is IRMS sin pi. Sorry. Okay, ma? This one is IRMS sin pi. I can split like this, no, ma? One horizontal component, one vertical component. Adjacent component is IRS cos pi. Opposite component is IRS sin pi. Okay, now see. Now, if you take the product of ERMS and IRMS cos pi, ERMS multiplied by IRMS cos pi, then it is called as true power. True power. Okay? What is meant by true power? This is the power which is responsible for doing work in the circuit. Circuit lo work cheyadaniki responsible power evaru idi. ERMS into IRMS into cos pi. Are you able to understand, ma? Similarly, if I take the product of ERMS multiplied by IRMS sin pi, then it is called as reactive power. Reactive power. Or you can call it as useless power. This reactive power does not do any work. Adi panemi cheyadu. Saradaga atu itu tiruguta untadu annamata. Are you able to understand, ma? And just if you take the product of ERMS multiplied by IRMS, so supply voltage multiplied by current, that's it. Then it is called as apparent power. And what is meant by apparent power? This is the power which appears to you as if this much amount of power is done, or this much amount of power is supplied, or this much amount of power is useful. But this much amount of power is not useful. Idi meeku anipistundi ante. This is the current passing. This is the voltage which you have supplied. Power ante V into IA kada. So this is the apparent power. 1 minute. Okay. Sima. So understood, Nama? Which is the true power here? ERMS multiplied by IRMS cos pi will become the true power. And what is meant by reactive power? IRMS sin pi multiplied by ER is called as reactive power. And apparent power means this is the power which appears to you as if useful work, but this is not useful. Okay, ma? So what is meant by true power? True power means actual power useful to do work. Useful to do work. And what is meant by reactive power? Reactive power is nothing but useless power. Okay, ma? Just it flows to and fro in the circuit. Okay, ma? మల్లీశ్వరి సినిమాలో వెంకటేష్ చెప్తారు చూడండి బేరర్తో, ఒరే ఏమన్నా అడుగుతావా, ఊరికి అట్టి ఇట్లా వాకింగ్ చేస్తూ ఉన్నావా అని. అట్లా ఇదన్నమాట. ఇట్ డజంట్ డూ ఎనీ యూస్ఫుల్ వర్క్, జస్ట్ ఇట్ ఫ్లోస్ టు అండ్ ఫ్రో ఇన్ ద సర్క్యూట్. ఓకే, నెక్స్ట్ దిస్ ఈస్ కాల్డ్ as apparent power, the power which you feel as if it is useful power. Are you able to understand? That's it. Similarly, this IRMS cos pi, this is called as wattful current. Wattful current. Wattful current means what? Current which is useful for doing work. Are you able to understand? So current useful for doing work. Okay. And what is meant by IRMS sin pi? It is called as wattless current. Wattless current. Just అటు ఇటు ఖాళీగా తిరుగుతూ ఉంటుందన్నమాట. Doesn't do any work. Okay ma? That's it. Okay ma? So power consumed by RL circuit ma, power consumed is equals to ERMS IRMS cos pi. Already we have studied no, ERMS IRMS cos pi is called as useful power. So that is the power which is consumed in the circuit. Clear? Or Sima, actually inductor does not consume any power no, already we have discussed no. Who consumes power? Only resistor consumes power. Inductor does not consume power. Capacitor also does not consume power. So therefore another equation of power which I can write is, just I can write IR square into R also, which proves that only resistance consumes power, inductor does not consume power. Are you able to understand? This is another equation of power. That's it. So this is the concept which we should study under RL circuit. అర్థమైంది కదా? So circuit containing RC ma. So just you draw what are the phasors for resistor. So this is VR, RMS, or just VR I will write, and this is IRMS. Clear ma? Voltage consumed by resistor, RMS current in the circuit, and this is capacitance. For capacitance, which one is leading, which one is lagging ma? Current is leading, voltage is lagging. So this is IRMS and this is VC. VC means potential consumed by capacitor. Combine both of them. So therefore this is VR and this is VC and this is IRMS. That's it. Okay. Now what is the potential you have to supply ma? Supply potential is how much? Supply potential, just you take the resultant of these two. Clear no? This is ERMS. So ERMS will be how much? ERMS will be is equals to square root of VR square plus VC square. Clear no? And what is this ERMS? This is the supply potential which you should give. Supply potential. Clear no? Now from the same supply potential, if you remove current, then what happens? ERMS, how can I write? IRMS multiplied by Z. So this is equals to square root of VR IRMS multiplied by R whole square, and VC IRMS multiplied by XC whole square. Clear number? So cancel IRMS, IRMS and IRMS. Then what I will get? I will get Z is equals to square root of R square plus XC square. Okay ma? So this is called as impedance of this capacitive circuit. Okay ma? Impedance of capacitive circuit. Okay. Now see the pi value here. Who is leading, who is lagging ma? Current is leading or voltage is leading? Current is leading voltage no? So therefore in capacitive circuit, current leads voltage by pi value. Clear ma? So what is the note point here we have to write? Note point is that in capacitive circuit, okay, current leads voltage. Current leads voltage by pi. That's it. Are you able to understand? Now here also we will write power consumed. Power consumed. Again same concept. Power consumed is equals to ERMS IRMS cos pi, or you can write IRMS square multiplied by R. You can write like this also. So this term proves that only resistor consumes power, capacitor does not consume power. Okay, ma? That's it. This is about. Okay, ma? Now next we are studying the last type of circuit, which is called as RLC circuit. Clear? Now these are the phasor diagrams. In the resistor, voltage and current, they will be in phase. In the case of capacitor, current leads voltage by 90 degrees. In the case of inductor, voltage leads current by 90 degrees. Combine all of them. If you combine all of them, we will get three cases, ma'am. Let us see what are the three cases. Case number 1. Case number 1 is VL greater than VC. This is my first case. Okay, ma? What is meant by VL greater than VC? Voltage drop across inductor is greater than voltage drop across capacitor. These two, they are in opposite direction, no? So we have to see which voltage drop is greater. So first case is VL greater than VC. Then how can I draw the diagram? Diagram I can draw like this. So this is VR, this is RMS, this is VL, and this is VC. I can draw like this. Okay, ma? VL is very large, VC is very small. Okay. Now can you say, how can I draw the supply voltage? Supply voltage, how can I draw? Chappan. ఆలోచించండి. అది హాఫ్ ఉందని ఎవరన్నా చెప్పినారా? ఎందుకలా? They are in opposite direction, no? Sima VL and VC, they are exactly out of phase. 180 degrees out of phase. You can directly subtract them. So therefore, if this much of VC will be this much of VL, no? So up to here, this is equal to VC only, negative VC. So this value and this value, they can get cancelled with each other. Are you able to understand? So this much amount of VC, same amount of VL, but VL in opposite direction, no? So they get cancelled with each other. Then what is the resultant? This becomes my resultant, which is called as ERMS. And this remaining value is how much? It is VL minus VC. Are you able to understand, ma? That's it, very simple. Clear, no? So therefore ERMS, how can I write? ERMS is equals to square root of VR square plus VL minus VC whole square. That's it. అర్థమవుతుందా ఏం చేస్తున్నాము? So from VL, the small part of VC I am removing. Remaining voltage is VL minus VC. That becomes my resultant. Resultant of VR and VL minus VC becomes the supply voltage. Okay. So this is my equation of supply voltage. ERMS is always supply voltage. Remember, VR is voltage consumed by resistor. VL is voltage consumed by inductor. VC is voltage consumed by capacitor. But this is the supply voltage which you should give. మీరు ఇంత ఇవ్వాలి, అవి దానికి కావాల్సినంత అవి కన్స్యూమ్ చేసుకుంటాయి. అది ఓకే. నౌ ఫ్రమ్ దిస్ యూ టేక్ అవుట్ ఐ వాల్యూ. ఐ కామన్ తీయండి. ఈఆర్ఎంఎస్ హౌ కెన్ ఐ రైట్? IRMS multiplied by Z. This is equals to square root of IRMS multiplied by R whole square plus VL IRMS multiplied by XL minus IRMS multiplied by XC whole square. Clear now? So IRMS, if I can cancel, then what is the Z value I get? Z value is equals to square root of R square plus XL minus XC whole square. So this is the total impedance of this circuit. Okay, ma? Total impedance of the circuit. Now can you say, is this capacitive circuit or inductive circuit? Chappan. This is inductive circuit, because already I said you, whenever voltage leads current, then it should be an inductive circuit. Here supply voltage is leading current, so definitely this is inductive circuit. So therefore what I write? This is an inductive circuit. As voltage leads current. Are you able to understand? Clear now? Power consumed. Power consumed. Same story. ER IR cos pi. Or you can write IR square multiplied by Z. Same concept. Clear now? That's it. So this is about VL greater than VC. Now you write the second case, try to draw the diagram. VL less than VC or VC greater than VL. Draw change daniki phasor diagrams. Sima. So what is case number 2? VC greater than VL. So what I will do, this much of VL I will remove from VC. Okay? So this VC and this VL will get cancelled. So therefore, what is the remaining value? Remaining value is VC minus VL. Clear ma? And what is this one? This is ERMS, supply voltage, which you should give. So supply voltage is how much? It is equals to square root of VR square plus VC minus VL whole square. Okay. Now again, if you take I common, then what is the equation I can write? Z is equals to square root of R square plus XC minus XL whole square. Clear ma? Now here which one is leading which one? Okay. So here Sima, when compared to, this is IRMS, no? When compared to current, voltage is lagging here by an angle of pi. So therefore it is called what kind of circuit? This is an capacitive circuit. So here voltage lags current. So voltage lags current in which condition? Only if it is a capacitive circuit. In capacitance only voltage leads current by 90 degrees. No? Same concept here also. So therefore it is capacitive circuit. Okay ma? Case number 2. Now what can be case number 3? Equal. That's it. Write down case number 3. So case number 3. VC is equal to VL. Clear ma? So if VC is equal to VL, let us see how we can draw the diagram. So this is VR, this is IRMS. Clear ma? This is VL and this is VC. So definitely both of them will get cancelled, no? Because they are equal. If both of them they are equal, then can you say supply voltage is how much? Supply voltage anta avutundi mari? VR only. Only resistor consumes potential in this condition. So ERMS is nothing but VR. Okay ma? So by this what we understand here, only resistor consumes voltage. Only resistor consumes voltage. Okay? Consumes voltage in the sense only resistor is responsible for consuming all the supply potential which is given. Okay? But here there is one point ma. All the supply voltage is consumed by resistor, but VL and VC they will also develop some voltages. And the voltages developed by capacitor inductor, they will be much greater than supply voltage. మీరు సప్లై చేసిన వోల్టేజ్ కన్నా ఎక్కువ పొటెన్షియల్ని ఇవి డెవలప్ చేస్తాయి ఇప్పుడు ఈ కండిషన్లో. ఇన్ కేస్ నెంబర్ 3, the voltage developed by VL and VC will be much greater than ERMS. But point is that they will not consume voltage, no, they will develop voltage, but they will not consume voltage, so no problem. Are you able to understand? I don't think it is of much importance, just. So therefore what I write here, now in this condition, if it is ERMS is IR, ERMS can be written as IRMS multiplied by Z norma. VR can be written as IRMS multiplied by R. So what I understand, IRMS, if I can cancel, then impedance of the circuit is only because of resistance only. Impedance is only because of resistance. Okay? Or you can write like this also. So for example, if I write Z is equals to square root of, or we will do one thing, we will write ERMS is equals to square root of VR square plus VL minus VC whole square. Okay, ma? Same relation how I can write VL is equal to VC, no ma? Potentials developed is same, no? So therefore VL minus VC will be how much? 0. So like this also you can write. Therefore ERMS is equals to square root of VR square. So therefore ERMS is nothing but VR. So you can write like this also. Understood, no? Now in this circuit, who is leading, who is lagging? Leading evaru, lagging evaru? ఇట్టంటే ఏమనరా? ఏమీ జరగడం లేదా అంటే దాని అర్థం ఏంటి? కాన్స్టెంట్ అంటే జీరో అంటే both of them, they are in the same phase. That is the meaning of this one, no? Clear, ma? So here current and voltage are in phase. Current and voltage are in phase. They are in the same phase. That is the meaning of it. Clear, no? That's it. Okay. Okay. So therefore in this condition, the power consumed when R, L, C, all of them they are present, then this is the equation, ER, IR, cos. In RL also same formula, RC also same formula, and in RLC also same formula, ER, IR, cos. Are you able to understand? Now see ma, here case number 3 what we have studied, case number 3, VL is equal to VC. This is what we have studied, no? Clear? This condition is called resonance. What is the name of this condition, ma? Resonance condition. So in resonance, VL and VC, they will be equal to each other. And what is VL? VL can be written as IRMS multiplied by XL. And VC can be written as IRMS multiplied by XC. So IRMS, if I cancel, then XL is equal to XC. Okay, ma? So what do you mean by XL is equal to XC? Resistance offered by inductor and resistance offered by capacitor, both are same. Oh, so this condition happens only in resonance. Okay. Now XL, how can I write? How can I write XL value? XL formula en raskunnam chudandi. XL can be written as 2 pi FL. Do you remember? 2 pi FL. XC 1 by 2 pi FC. Clear, nama? So you take F square, F and F square. F square is equals to 1 by 2 pi whole square multiplied by L into C. So therefore F is equals to 1 by 2 pi root LC. Okay, ma? And this frequency is called as resonating frequency. Resonating frequency. Okay, ma? What is meant by resonating frequency? Resonating frequency means if you give this much of frequency to RLC circuit, then circuit will go into resonance. That's it. Frequency anta chadina manam 50, 100 ila తీసుకున్నాం కదా. So if you take this much amount of frequency, which is equals to 1 by 2 pi root LC, and if you supply this much of frequency to RLC circuit, then RLC circuit will go into resonance. Ade resonance loki vellipotundi. Clear, na? And what is the importance of resonance? If circuit goes into resonance, its efficiency will be maximum. That is the meaning of it. Clear? So write down. So if a resonant frequency is supplied, if resonant frequency is supplied, Okay, ma? RLC circuit goes into resonance. RLC circuit goes into resonance. That's it. Okay? And what is the importance of resonance? In resonance, efficiency is maximum. Efficiency is maximum. Okay, ma? So then we study one more term which is called Q factor. Q factor. వీడు మామూలుగా నడుస్తేనే సౌండ్ వస్తుంది, షూస్ వేసుకోరు. సిమా Q factor. Sima, in resonance what happens is that voltage across inductor and capacitor will be very large. So even it is larger than supply voltage also. If supply voltage is 10 volts, voltage across inductor is 1000 volts. Voltage across capacitor is also 1000 volts. Very large. But they will not consume voltage, just they will develop voltage. That's it. Are you able to understand? So Q factor is, what is meant by Q factor? Q factor is nothing but voltage across inductor or capacitor divided by supply voltage. Okay, ma? So it means when compared to supply voltage, and this is at resonance, ma. Q factor will define at which condition? Only at resonance only. Okay? So it means when compared to supply voltage across inductor and capacitor is how many times bigger? That is called as Q factor. And in resonance, who will consume this total voltage? Resistor only, no? So instead of supply voltage, can I write IRMS multiplied by R? I can write, no? Because in resonance, who consumes this supply voltage? Ma? Only resistor. Are you able to understand? So therefore, this equation also can be written as Q factor. I can also write it as VL or VC divided by VR. I can write like this. Okay? What is the reason? Reason is, at resonance, supply voltage is nothing but voltage consumed by resistor. Already we have written that statement, no? So you should remember it. Okay? So therefore, Q factor can also be written as VL. Let us take VL divided by VR. Okay, ma? So VL can also be written as IRMS multiplied by XL divided by IRMS multiplied by R. Therefore, Q factor can also be written as XL divided by R, or you can write XC divided by R, because XL and XC both are same, no, at Q factor. So you can write like this also. Are you able to understand, ma? Now we will do one thing. We will try to derive one more equation for Q factor, ma. Now let us see how we can derive. Okay? See. So resonant frequency, what we have written, 1 by 2 pi root LC, no? Resonant frequency is FR is equals to 1 by 2 pi root LC. Therefore, from this equation I can write 2 pi FR is equals to 1 by root LC. I can write like this also. And what is 2 pi FR? 2 pi FR is nothing but omega, no? Omega R is equals to 1 by root LC. 2 pi F ante omega ne kada. So 2 pi FR can be written as omega into omega R. It is 1 by root LC. Okay. Now if I go to Q factor, చూడండి కేర్ఫుల్గా ఎలా స్టెప్ బై స్టెప్ మనం వెళ్తున్నాం అనేది. ఇఫ్ ఐ గో టు Q factor, XL by R. XL is nothing but 2 pi FL divided by R. This is XL, no? What is 2 pi F? 2 pi f is nothing but omega. So omega L by R. So take this value and substitute here. So Q factor can also be written as, instead of omega, I can write 1 by root LC multiplied by L by R. So therefore Q factor can also be written as 1 by R root L by C. So this is second equation to calculate Q factor. Understood, no? So two equations of calculating Q factor. This is my first equation and this is my second equation. Understood, no? So sometimes questions were given on this relation also, ma? So try to carefully understand how we have derived it. Okay?